Hey guys, this is a lesson on complex numbers. Complex numbers are also known as imaginary numbers, and this is a tool to help us if we have a negative sign under an even index for a radical expression. Okay, so remember that if we had like the square root of -25, we have to say that there is no solution to that. The cubed root of -125, that one it's okay to say the answer is -5 because -5 times -5, so two negatives will make a positive. -5 times -5 is a positive 25, but times another -5, right? -5 times -5 times -5. Negative times a negative makes a positive, multiplied by a third negative makes it negative again. So that one's okay. The fourth root of, let's see, 2 to the power of 4 is 16, right? So the fourth root of 16 is 2, but the fourth root of -16 does not exist. So this is just for context. It's a non-real answer, but the fourth root of 16 is a real answer because 2 times 2 is 4 times 2 is 8 times 2 is 16. -2 times -2 is, let's just, -2 times -2 is a positive 4 times -2 is a -8 times a -2 is a positive 16. So you're never going to get an even multiplication an even number of times that will give you a negative answer. An odd number of times is fine because -5 times -5 times -5 is okay. Those two make it a positive 25, multiplied by a negative again gives you a negative. Positive, or sorry, -5 or +5 times -5 is never going to give you a -25. All right. So if the index is even, don't worry about if it's odd. If it's even, you cannot have a negative under the radical sign. Okay. It does have a solution, but it's not a real number solution. I is an imaginary unit whose square is -1. Okay. So the square root of -1 is I. Okay. I squared is -1. I squared is -1, and the square root of -1 is I. Right? Because if I square this side and I square this side, the squaring gets rid of the square root, and it's -1 is I squared. All right. So the square root of -49 can also be written as the square root of -1 times 7 times 7, right? So that means you can either say it's 7 times the square root of -1, and then the square root of -1 is I, so we can also say it's 7I. Good. A complex number is a number that can be written in the form a plus bi, where I is that imaginary term. Okay. The imaginary unit is why I call it imaginary number sometimes. A is a completely real number, and B is the coefficient. B is the coefficient of I. Good. All right. Remember that it's always the whole number first, or the real number first, and then the imaginary number second. Okay. Now using the I, we can now find solutions to radical expressions which contain negative radicands. All right. So 3, oh, that's the number 3. That was being 3 multiplied by 3 is the square root of -9, which we can then rewrite as the square root of -1 times the square root of 9, which is the square root of -1 is I, and the square root of 9 is 3. So our answer is 3I. And that is true, right? -9 is just -1 times a +9, if you want it to be. 100, the square root of 169. Well, if we bring back our little chart, 169 is 13 squared. So we want to change that. Excuse me 1 second. All right, guys, I just made a whole video. And I shut it off after those first 5 minutes somehow and didn't know. So new piece of paper. I'm gonna finish it. Will it be easier this time? I don't know. All right. So we're on number 4. I think that's where I stopped. The square root of negative 169 is equal to the square root of -1 times the square root of 169, right? Which if we look at the list, 169 is 13 squared. So we know that the square root of -1 becomes I, and then the square root of 169 is 13. So the square root of -169 is 13i. The square root of -149, we already did it, but we can do it again. It's going to be the square root of -1 times the square root of +49, or the square root of -1 times 7 times 7, right? And then you take those two sevens out and you get 7 times the square root of -1, which is 7 times I. Also, like that example, like the example number 3, we have -1 times square root of 9, the same thing as -1 times 9. All right, so you can write it like that. You can write it all together. Kind of like we practiced when we were multiplying and dividing. Whichever looks cleaner to you. Because I feel like this looks cleaner now, but I've been doing it that way this whole unit. Anyway. Negative square root of -64. The negative is just going to remain on the outside, okay? -64 is -1 times +64. We know that 64 is 8 times 8, so it's going to be a negative. The -1 is going to convert to an I, and the 64 is going to convert to an 8. So we have a negative I times 8. You always want the I behind the coefficient, so it's -8i. Good? The square root of -12. So again, there was only a negative there because there's a negative outside of the radical. Here we have the square root of -12. That's going to become the square root of -1 times the square root of 3 times the square root of 4, because 3 times 4 is 12, and then the square root of 4 is 2, right? So that's going to be I square root of 3, I times the square root of 3 times 2, because the square root of -1 is I. So it's going to be 2i square root of 3, final answer. Good. Here now, we're going to simplify the -18, but we also have to multiply it by the -3, or by the +3 if we take anything out from the radical, which we will, at least an I, right? Because it's a negative. That's going to become 3 times the square root of -1 times the square root of 9, let's say, times the square root of 2. 9 times 2 is 18, and then the square root of 9 is 3. So that will turn into a 3, that will turn into an I, and I'll only have the square root of 2 left. 3 times I times 3, right? That 3 is just being carried. The -1 becomes an I, and that 9 times 2 is the 18. 9 becomes 3. 3 times 3 is 9i square root of 2. Good. All right. 5 times the square root of -12 becomes 5 times the square root of -1 times the square root of 3 times the square root of 4, right? Because the -1 becomes I. We're just trying to simplify. You can't simplify 3, but the square root of 4 is 2. We need to bring down that 5. So the 5 is just carried. The -1 becomes I. The square root of 3 remains square root of 3, and the square root of 4 becomes 2. 5 times 2 is 10i square root of 3. Good. All right. Here we have the square root of negative 234. 234, you want to check, see if it's on this list of perfect squares. We have, well, it doesn't go that far. So you can just say the square root of 234 without the negative sign. It's not a perfect square. So you're just going to say 234. And we're going to divide it by, let's start at 81. Yeah. 64, 49, 36, 25, 16, 9. Okay, we found one. 234 divided by 9. So that's going to change to the square root of negative 1 times the square root of 26 times the square root of 9. Negative 1 becomes I. The square root of 26 remains the square root of 26, and then 9 becomes 3. So we now have 3I square root 26. Good? Right. Now they are asking us, does I apply to the cubed root of a number? Why or why not? We know it does not because we saw that we only have a negative under an even index that is impossible with real numbers, right? So let's look at the number 6 to the power of 3, right? It's 216. 6 to the power of 4 is 12,906. So if we had the square root, 6 times 6 is 36, right? The square root of negative 36, the cubed root of negative 216, and then the fourth root of negative 12,096, and then the fifth root of whatever that is, 7,776, right? All right. This is not possible because negative 6 times negative 6 does not equal negative 36, right? However, if I have a negative 6 times negative 6 times negative 6, well, a negative 6 times a negative 6 will give me a positive, and that positive times a negative will take me back to a negative. So if it's an odd number, even number, it can't equal a negative, but an odd number of multiples can give you a negative. So if it's odd, you don't need imaginary numbers. If it's even, you need imaginary numbers. Let's look at 1, 2, 9, 6. So we have negative 6 times negative 6 times negative 6 times negative 6. What's going to happen? Negative times a negative is going to give us a positive, times a negative back to negative, right? And then times a negative again takes us back to a positive. So it is not possible to get negative 1296. Negative 6 5 times, that will work because it's a negative times a negative gives us a positive, times another negative gives us a negative, times another negative gives us a positive, times another negative gives us a negative. So we only need the imaginary numbers for square roots, fourth roots, sixth roots, eighth roots. Okay. Oh, and obviously that was supposed to be negative. Did we already? Okay. So the square root of negative 36, it will not give you an answer. The cubed, oh, sorry. Quit. The cubed root, no, sorry. The cubed root of negative 216 will give you an answer. The fourth root of negative 1296 will not give you an answer. And then the fifth root of negative 7776 will give you an answer. Good. So that is why it does not apply to the third root or the fifth root, and it doesn't need to. Okay. When adding, subtracting, multiplying, and dividing complex numbers, it would probably be helpful to think of I as any other variable like X and treat it as such. Except that if you get I squared, switch it to negative 1. Okay. So basically, 12 to 21 are just reviewing how to combine like terms and a little bit of multiplying binomials. All right. A little bit of review for you. So here, we always need to have the answer in A plus BI form. Here we have 5 minus 9i plus 9 plus 3i. I don't even need those parentheses. So I'm just going to rewrite it without the parentheses. And then I'm going to look at common like terms. 5 and 9 minus 9i plus 3i. So 5 and 9 become 14 minus 9 plus 3 minus 6i. Good. So we're just combining like terms. And you always want to have it in A plus BI format. So your first term followed by the coefficient of I as the second term. Good. Now we have 3i plus negative 5 minus I. Again, you don't need those parentheses because there's no minus sign. If there was a minus sign, we would need to distribute the minus sign, but we don't. So that's just 3i minus 5 minus I. The like terms are the 3i and the negative I. So we have, and I'm going to go negative 5 first because that's A BI form. A plus BI form is the whole number first, plus 3i minus I or minus 1i. So that's negative 5. 3 minus 1 is 2i. Negative 5 plus 2i. Good. All right, here we're distributing a negative. So here it's 4 plus 7i minus a negative 8 is plus 8 minus an I minus a positive I is just minus I. So 4 plus 7i plus 8 minus I. 4 and 8 plus 7i minus I. 4 and 8 is 12, right? And then 7 minus 1 is 6i. Again, we're distributing a minus sign. Just be careful with the minus sign. It's the hardest part. 7 minus 6i. Just notice that we have just been treating I like X. You're not doing anything special. So minus a negative 7 is plus 7. And then minus a plus 6i is negative 6i. So now we have 7 plus 7 minus 6i minus 6i. 7 and 7 is 14. 6 minus 6, negative 6 minus 6 is negative 12i. So it's 14 minus 12i for that one. And those are the examples of addition and subtraction of binomials. Now we're going to multiply a monomial times a monomial, and then we'll move on to monomial times binomial, and then binomial times binomial, and that will be all. So when multiplying, it's just like any other variable, okay? 9 times I times 6 times I. We're going to multiply the 9 and the 6 together, and we're going to multiply the I and the I together. So 9 times 6 is 54. 54, and then I times I is just I squared. Now, remember, anytime you see I squared, change it to negative 1, okay? So that's 54 times negative 1. negative 54. Negative 14i times negative 3i, negative 14 times negative 3 times I times I. Negative 14 times negative 3. 42. I times I is I squared. Remember, that is now a negative 1. So it's 42 times negative 1. It's a negative 42. And you're done. Good. Now we have a binomial and a monomial. So it's going to be 7i times 9 times minus 7i times 6i. 7 times 9i minus 7 times 6 times I times I. So you can just say 7i times 6i, but I wanted to put it in order. We're going to multiply the number by the number by the number, and the I by the I. 7 times 9 is 63. I. And then 7 times 6 is 42. I squared. Good. 63i just remains. Negative 42, but that I squared becomes a negative 1. So it's 63i plus 42, because a negative 42 times a negative 1 is a positive 42. And we're going to switch places. 42 plus 63i. Good. All right, moving on to like binomial times binomial. You're just foiling, okay? So we can just go first, outside, inside, last, okay? First, we have 4 times 4. Outside, we have 4 times negative 6i. Inside, we have 6i times 4. And then last, we have 6i times negative 6i, right? Okay, so that all becomes 4 times 4 is just 16. And then 4 times a negative 6i is negative 24i. 6i times 4 is a positive 24i. And then negative 6 times positive 6 times negative 6 is a negative 36. And then I times I is I squared. Got it? And if you'll notice what we were multiplying, 4 plus 6i times 4 minus 6i, these are reciprocals, right? And so we're going to have a minus 24i plus 24i. Those are going to cancel, and we're just going to have 16 minus 36i squared. Because the only difference was addition or subtraction of the second term. Good. We're not done yet, because I squared, again, has to be changed to a negative 1. So it's 16 plus 36, which is 52. Good. All right, now we have 4 minus 24i times 6 minus I. Same exact thing, okay? So we're just going to FOIL it. First, outside, inside, and last. First term is 4 times 6. Second term is 4 times negative I. Then we've got inside, negative 24 times a positive 6, negative 24 times 6 times I, right? With that 24. And then last, we have negative 24 times negative I. Four times 6 becomes 24. 4 times negative I is just minus 4i. Negative 24 times a positive 6 is a negative 144i. And then negative 24 times a negative I is a positive 24I. Oh no, I forgot the other I. That I and that I. So it's positive 24I squared. All right, we can combine. 24 just remains 24. Negative 4I minus 144I, you're just combining them and you get 148I. Negative 148I. And then you have plus 24. And that I squared gets turned into a negative 1. So it's 24 minus 148I minus 24. 24 minus 24 is 0. So it's 0 minus 148I. You could probably just write it as negative 148I. Okay. All right, our very last one is 8 minus 4I quantity squared. That does not mean 8 squared minus 4I squared. That means 8 minus 4I times 8 minus 4I. Good. First is 8 times 8, so that's 64. Outside is 8 times 4I. So that was a negative 4, positive 8. Negative times a positive is a negative. Inside is a negative 4I times 8, so it's a negative 4 times 8I. And then last was a negative times a negative, so it's going to be a positive. 4 times 4 times I times I. Good. We've got 64. 8 times 4 is 32 minus 32I. If 8 times 4 is 32, 4 times 8 is 32. And then 4 times 4 is 16I squared. 64. Negative 32 minus 32 is a negative 64I. And then plus 16 times the negative 1. 64 minus 64I minus 16. 48. So we have 48 minus 64I as our last problem. All right, guys, thank you for watching and have a wonderful day. Yay, I actually recorded this one.